Welcome to my documentary and extended description of the upcoming Dallas Free Energy Convention workshop. So I want to talk about the workshop, but I also have a very long video documentary that has never been shown before. This is part of the DVD series that hasn't been on my YouTube channel yet. There's some elements that are. So we're going to talk about that, we're going to show that, and I will cut and paste it and interject different information to explain what was happening 15 years ago. So before we do that, let's get into the upcoming convention. I've already done some videos on that, and I just want to show a few more things and explain what the workshop will be about. So again, the details are on the website r-charge.com under conventions, and there'll be a link in the description here of this video. So this is all about free energy. What's supposed to be impossible is real. And I'll be showing in industry showing in the meeting, in industry, this technology is already being used. And so it is not impossible. You're just made to believe that it is. So we will look at magnets. We will look at electromagnets. We will look at mechanical devices, perpetual motion machines. Oh my. So let's go over some of the kits that we'll be doing in the workshop. Now these kits are all doing something very special. And we're going to have, I think, about 5 different kits. And what I did, the initial one that we did was this one right here back in 2010. So this was the monopole system, and we were working with Bedini at the time. And so we upgraded that later on to what we call the dual pole motor here. So in other words, this was just one coil driving it on one side, and then we have 2 rotors on either side on this one. And this is another motor yet, what we called, well, it's really the Newman motor, but it's modified from that. And we have upgraded from that. This was in the second meeting, what you'll see the video, we were making this in the workshop. We were making this one in the first 2010 convention, the big one that we did, and then we upgraded or moved on to the window motor. And you'll see in all my big conventions, my big demonstrations have always been the window motor. It's a very good motor. And this is what it is too. And we'll talk about this later, but this was in the Porsche. Almost identical one. So in the workshop, which will be all day long, I believe Friday is what we'll do. This is March 5th, 6th, and 7th, so on the 6th of March, on Friday, we will give people the opportunity to make as many of the kits as they want. So either, these ones are called the schoolgirl motor, which was the same as this. This is the later model that I'm doing right now that can be used in many different configurations. So that is 3 different models here. This is actually running off a reed switch, this one. This is the original SG one that I just showed the other day. And that's the main model of it that will be used. And this is where it came from. And this is the top spinner. It's too loud to leave on. So basically which is what we show in the kit, in the book, called Mechanical Oscillator Energizer Kit, History and Diagrams and the Nature of Science in Open Context. And I just have all things on there. From him, through him, and to him are all things. How to do science. And that's what this meeting is going to be about as well, is the nature of science. And so it's very important, the details that we'll go over there in order for you to succeed. And also, my goal is to explain why it's real, not just and how it's real, not just that it's real, and useful, of course. So let's go into some of the models again that will be available. So there's this one, there's the fan, there's the monopole, or the dual pole. We won't have a monopole besides this one, like a bigger one. Well, actually, we will have a bigger monopole. And then this one right here, it was on. This is the Benitez kit. This one is not. Yeah, there we go. So this is part of the patents that I teach on. This is a former patent that's expired. This is a patent that's expired. This was never a patent, even though Newman tried to get a patent. And I also teach on radio frequency systems that are also free energy. So this will be a kit that we can, a workshop kit. This is a new kit that no one's seen. Well, a few people have seen some of the meetings. But we'll make this available. And in that patent, which you can see in my earlier videos, where Benitez clearly states self-sustaining system based on this. This is the induction coil, very small one. So we'll have 1, 2, 3, 4, 5. I think there's 6. I'm missing one here. But anyway, let's go over the fan. The ideal one will be the fan. Now, because that fan is made by the billions, there's billions of those fans, like in every one of your computers has a brushless motor fan. And so they're everywhere. And I've shown this for 20 years now. I did a demonstration all across the country on many of the biggest universities, colleges in the United States. Over 200,000 individual students I talked to and demonstrated that fan. So it was the biggest demonstration of unconventional free energy ever done. And that was all the way back in 2005. Yeah. So 20 years ago. Now it's 2026. So this fan, we can run it, measure the power input before it's modified, and then we measure the airflow with the airflow meter. Then we do the conversion, like we'll show one unmodified. We'll then modify, whoever wants to do it, we'll modify the fan. Now we're charging a second battery for free, because we're going to be measuring it and seeing that the airflow is the same as it was before it was modified. And the input from the input battery is going to be drawing the same amount of amps. And so now whatever we charge in the second battery is free energy. because we weren't able to do anything extra before. And it's not even expected that we could have done that. So now, it's not about whether you can keep it self-sustaining, which you can. It's about whatever extra energy you get out of that battery is free. Now these systems right here, it's not as easy to figure out that like you would with the fan, because this fan is really efficient, supposedly 96% efficient, and so if I'm running at the same RPM, same airflow, with the same input as I was before, then anything else is free. So it's as simple as that, right? There's nothing to debate about. And of course, we've been using these for 20 years now in my home, whatever. So this was the latest that we were doing for the Amish, where they had a nice little handle on it and everything. And we'll probably make those features available in a nice little box there. Of course, they wanted to do that with the lithium batteries, but I don't want to do the lithium batteries. Anyway, we have lithium iron phosphate, which we were going to be focusing on in the meeting. And I'll go over all that in the meeting. So now, while we'll have those, we'll also have these bigger motors here, and ones that I haven't shown yet to you that will be new. There'll be a new version of this. This is our bigger version of the dual pole, and this has, both of these have generator coils as well as motor coils for each, and there's a rotor on either side here. Now I'm not running them because you can see that in my other videos. It's not important to run it right now. Now this one is a bigger version of this. And actually we have a newer version of the smaller one that is for sale, not this one. So this is the rotor of it. You can see it's bigger. And see how I can, it's kind of neat, like a gear. I can turn it. And I often do that, run a whole bunch of them side by side. It's kind of neat. Anyway, this one has 8 magnets, this one has 6, and this one's not encased, so it was kind of dangerous, but this one is encased. So then, the Porsche motor had the same motor as this, but actually it was an inch smaller. This is 13 inches, that one was 12. And it's got the 6 magnets on here too. But what I'm planning on doing for the meeting is the very bigger one. I've designed it all out for some time yet, but some investors didn't work out, let's just say, and so therefore I wasn't able to complete that project until now. So at that meeting coming up, we're looking at having the 14-inch rotor. This is 6-inch, very powerful motor, which originally we were going to make into a motor and a heater and a charger all at once, which we can do. So that's the plan. This particular one we will plan on putting into a golf cart for the meeting, if I can find one. Anyone have one to donate? I'll take it and convert it. We did do one about 2 years ago. Basically, the cars that you're going to see that I converted the Porsche as part of this documentary that will be later on in this video here, we'll get into in a moment. We were basically running like a big golf cart because we were using golf cart batteries just at a higher voltage, like typically 144 volts. So I want to talk about that and the details in the video, but I wanted to explain more, like you can actually see this spin here. Watch that. You can see this little one spinning with it. It's kind of funny. While I was moving, I could see it move back down here. So this one we'll try and squeeze into a golf cart. We can always move batteries around, whatever. And it'd be good for Dallas and Texas because they have a lot of golf carts down there. I usually do, on a bigger meeting, a bigger demonstration. So we've done 3 boats, the big one that you'll see shortly, and 2 other smaller ones we've done, where we've converted them to run for free by rotating the batteries around. And so it's fitting that we did that. Now I also have here, I don't have it out of the box, but a watercraft. This is a small one where we put this motor in. And you'll see that as well at the meeting. So I think what we'll do is, do a variety, as many demonstrations as we can. We've got a couple of new motors coming out in this meeting. And we're going to get into the details of proper charging in a free energy in a high COP system. What pretty much almost everybody's missed, and so I've been stressing it for years, a certain point. I'm not going to even mention it right now because it's going to be the theme of one of the major themes. And it's exactly the opposite of what all of you expect. You expect something totally different, and I'm not going to get into the details yet because it's going to be a big reveal. And I've had one customer who has really finally done what I've been asking for years to be done, and it's really, really exciting. So hang in there for that, and we'll see if, I don't know, like I'll probably record it, but I don't know yet what I'm going to do with that video. I have to decide, like whether we go live with it or what we do with that information. We'll see. So, I forgot to mention these books. So I did mention this one. Then we have the Kit 1, which corresponds to these coils here. That, again, that will be available to do in the meeting. And so we'll just do all of these various kits at the same time all day. We have from 9 o'clock till 9 o'clock with lunch and dinner breaks where we can go at it. And it's going to be a really informal day where there's a lot of dialogue, questions and answers, but building. That's what people want. They want to build. They want to see what they're doing wrong, what they're doing right, what to look out for, and we just go at it. It'll be real fun. We've never done multiple at the same time, multiple kits. Now we say we have 5 or 6 of them going, and maybe even some of the bigger ones. And so it's really exciting to think about how that will work out. And I remember the last time we did this was in Chicago. We I think had 30 different of these fans built. And I think only 2 of them were just about almost finished, but the rest of them were finished. So anyway, we have these various kits, and the kits come with extensive books. Like both of these, Resonance Kit 1 and 2 are 100 pages almost. This is like 89 pages, and it's small print too. And then this one is 100 pages. And then we have in between those kits the Don Smith book. So that will be on the final day on Saturday. We'll get into all these resonance and solid state versions of the free energy systems. But I'm not really focusing on that part here. This is all the first day and second day stuff. We can do this kit in the workshop as well on the second day. So then what we'll also be doing is the battery chargers. Now in this documentary that you'll see coming up here in this video, you'll hear a lot about the battery charging, and it overlaps with these systems here, in that what we wanted to do first, we solved two major world problems. Two. Now, I'm not saying that we did it in and of ourselves. There's a whole history that I teach on. And I want to say this clearly. I'm not the inventor. I mean, I am an inventor, but I'm a facilitator. I'm making this happen. I'm a historian. I'm showing you the history of science, real science, and neglected to be admitted science. And so what I'm doing is I'm showing you the history of this step by step, and I'm demonstrating it. Like, so people say, well, you can have a patent and it doesn't have to work. I'm showing you their patents, what their claims are. I'm showing you a lot of different patents that I'll be actually demonstrating work. And you can see, and in the workshop, you can build it yourself. And that's what the fan is, the most, I think, effective way where you can actually convince yourself, if you're a skeptic, and see that. And you'll see this boat that I drove around, and I only had just finished it in 2011. And I had that boat for 3 years. And I didn't need to charge the batteries. I rotated the batteries around. 2 Anderson connectors, like we have in this forklift charger here. Here's an Anderson connector. Right here. So I would just literally, turn the boat off and rotate the 2 connectors around from the charging battery to the input battery, and just keep going. So that's kind of old news, but for many of you it's new. It's something that you didn't even know happened. And so I teach on history. I show all this history that's suppressed and real, but it is in front of your own face. If you bother to look for it, you can see it's right there, and it always has been there. God has always left a witness for the truth, and that's another whole story, I guess. So let's talk a little bit about the battery chargers. It's going to be talked about in this documentary, but I'm only giving you video number 2, and it's highly cut to make it you don't fall asleep watching it. I tried to edit it just now in a way that got straight to the point. There's a lot of dead space. People complain about my long videos, so you know what I mean. So right here, I've been charging this all day. This battery here, we've been working on. Whenever I've had a battery charger to test, I bring it here and we work on this battery. And sometimes I'll do batteries for people. And I've already mentioned this in a previous video, but you can see here, this is our biggest charger right now. You can see the battery voltage is 50.4. I don't think you can see it maybe from there, but this battery has one cell missing. This cell right here is not connected. It's connected to this one, and the battery's resting, and it hasn't even finished charging. So let's start it up here. With power level 2 out of 6. Now, this has 6 power levels, so you can actually run smaller batteries, but this is a fairly large forklift battery. But what's going to happen is this is going to sit resting at the same voltage as if it had 24 cells, but it only has 23 right now. The last cell we're still working on coming back on that particular one. So I want you to be able to hear me. So I'm going to turn it off. But this is our various chargers. These are our various chargers here in size difference. So this is the 48. It also can do 36 and 24 volts. And this one is our 12 volt one that cycles the batteries, so it loads them down and charges them up so that you can actually measure the amperage, and it takes some cycling to bring the batteries back usually, so this one does it automatically. And this one, there's a 12 volt, a 24 volt, and a 36 volt model of this. So this is our mid-size industrial charger. This is our 10 amp charger, which is also a 5 or a 10 amp charger. And this is our 5 amp charger here. It's one of our first chargers that we made. And this is the little oscillator that is also a very handy tool. Now these are things we'll talk about in the meeting, and you can look at previous videos where I've described all these. We have more chargers than that. We have custom chargers and all sorts of things, but these are also chargers here. So this is the first problem of alternative energy, where the batteries failing is the biggest problem still to this day. We have solved that completely, and that's for all battery chemistries. So the highest levels of countries which we have dealt with personally at the highest levels have told us officially, to my own shock, I could list the country that I was expecting to receive this energy, and they came back and said, we sell batteries, we're not interested in bringing that to the public, but we will use it internally, but they will not promote it. So this is known in industry, in the battery charging world, but it's not going to be promoted because selling batteries makes money. So I deal with this all day long with people doing power estimates and dealing with their batteries, and we've seen probably over 10 million useless batteries come back from our customers over 20 years. And the batteries are getting better, not worse. So we don't see an end of life to them. And you say, well, how is that possible? It's negative entropy or negentropy. So we don't see this degradation, this degrading of batteries only under DC and other abrasive pulse charging. What we're doing is unique, both in the motor side and in the solid state regular charging. So that solves one problem for a world problem, which also solves the pollution problem. This stuff is the energy side and the battery side too, in which solves another major problem, which has been solved for over 100 years already. So we are looking to do more research and development in other avenues as well. We're involved in hydrogen research for many different applications. So let's move on to the video now that you're going to see, and I'm going to talk about a few things just to clarify, because it bounces around a little bit and you're looking at different video feed. So what I'm going to do is talk you through ahead of time so it makes sense what you're going to watch. So the main part, the main documentary, if you will, is about the 2011 convention, the last big one at the Coeur d'Alene Resort in Idaho. I lived there from 2009 to 13 and worked with Bedini every day for about 5 years, is that? 4 years? And before that I was flying in there. So I eventually decided, let's do a convention. And within a couple of months, I threw it together, just like I'm doing with this one. I just decided literally last week to do a convention. And we'll see what we can do in 2 months. And so they were all amazed. We had 400 people in 2010, the first one. Actually, there was 2 in 2010. There's one that was only 50 people. in Sand Point. And then we had another one later that year at the Coeur d'Alene Resort where 400 people came. And they were from all over the world. And it was truly a historic event. And then we had another one the next year in which it was also historic, is that what you will see here in all the things that were shown. Now I'm only going to show the vehicles in this video. There was still all the tabletop models that were running, the 30 coiler, the 10 coiler, 12 coiler. I had ceiling fans and all that were running. And so we didn't do any of the solid state high frequency Don Smith stuff that we'll be doing this meeting. So while that was really impressive to see all these things, it was still rudimentary. It was still like basics. It wasn't really advanced. It was advanced beyond what other people were doing, of course, but so this meeting will be highly tuned from any meeting that I've ever done, and very calculated. I've already planned it all out. And so what we're going to offer at this meeting is a 6-point solution plan. And like one point of that plan is in reference to demonstrating a real model. And of course, before that is the design, the theoretical side. And there is 6 total points to getting it to the place where it's established in everybody's mind as real and real science. And it's largely psychological, right? Because the attacks against the idea are, again, manipulation and psychological matters. So even if you can demonstrate something, if people can't reconcile in their heads, it doesn't work. So you have to really accomplish all these tasks. And I've never really done that fully until now. Like all the stages. And one of the stages that has just been done will be this big announcement that I'm going to make. But it's not going to be just an announcement. It comes with a whole package. So there's a whole teaching here that it will be demonstrated along these lines. And it relates to what we've been saying for years. And like I said, it's finally been brought to the level beyond even the way I've been doing things. So it's really exciting. I don't want to get into it until the meeting. So you'll have to wait until then to understand what I'm fully getting at there. Nevertheless, I'm showing you all these things. Now let's go back to the video that we'll watch here that's part of this video. So again, the context of this documentary is about this 2011 meeting, the final one. And I will add more context to it by telling you in the end, the very next day after that meeting, following the next year or so, everything was taken away from me. Everything. As a result of showing those things. And it was extremely hard to deal with. And so it has cost a great deal to me to bring about all this stuff. And I'm trying to persevere through that. And I do appreciate the support that many of you have given me, at least in word, and those who have, helped over the years in various ways, and even buying products and all that. But I want you to know that at the beginning, before you watch all this, because everything looks fine and dandy in the video, but then immediately after, many of the people who praised me in the videos, in the meeting, turned on me the very next day. And obviously not everybody, but, so while it's all very uppity, and you'll see, there was all sorts of things happening behind the scenes, unbeknown to me, until it finally appeared. Anyway, let's not focus on the negative here. Let's look at the details. So I want to explain now that there was a 2010 meeting, two of them, but the main one where you see, just so you understand and don't get misunderstandings, I want to be clear here. We made the Porsche in 2010 with a conventional forklift motor. And at the very end of this video, you'll see me driving off. And I don't want to let you think that somehow I got that Porsche finished with this motor in it and drove off with it, because it wasn't ready actually. But in 2010, we did have it running with the conventional motor in it. After that 2011 meeting, where I had this in there, and I actually did run it, but it wasn't roadworthy yet. But since everything collapsed the very next day, was the beginning of the collapse, I then sold that motor because my manufacturer cut off all relations to me. And I wasn't able to produce that exact motor. That's why this one is slightly different, because I went somewhere else. I got it done. So I drove off at the 2010 meeting. That's where that's ending there. And maybe I'll make an indication of that later on in this video. But I want you to understand that I wasn't driving it at that point. That was 2010. So there was very little that is shown here from the 2010 meeting. The big Ferris wheel that we made, 13-foot one, that one was shown first in the 2010. It wasn't really that significant, to tell you honestly. It was a big monopole. And you can see some of my videos on my channel here where I show just a small coil turning that wheel, which was kind of significant in some ways. But Bedini wanted to mystify it like he always did, and try to make it bigger than it, like more important than it really was, in my estimation. To me, I didn't see any real practical power in it, like I did with the boat and the car and the lawnmower. And that way, I was trying to do something that people could relate to as something practical. So anyway, we were trying to do another bigger Ferris wheel that you could actually sit in, and it was going to be, I think, double the size or something. And then the guy who was building it never got it finished for whatever reasons. I can't say. It's pretty bad. But whatever. So we never finished that, so we brought the other one back, and then you see it spinning there. And that one, at the second meeting, was supposed to be powering a big light show at night, but they refused to do it. So that was a big failure. That never happened. But so now, couple of things then. So I'm talking about because there's a progression of what I was doing. So in 2007, I had this rider lawnmower, right, that it was kind of failing in all different respects, right? It was an old rider lawnmower, and I had a really bumpy property, my first house, and I was just itching to have that turned into electric, and this kind of electric free. So I guess over the winter I had accidentally put the blades on backwards or something like that, and I got to cutting the grass and it just wasn't cutting very well. So I said, forget this, I'm doing it. And so Pat, who was sponsoring me with some money every month, gave me like $500 a month, and I put it towards this lawnmower. So in like 3 months, I built this rider lawnmower monopole with this type of, well, this system right here, right? Which doesn't give you much torque, right? It's not really meant to be a motor. But I showed, because I was a mechanic, I have to be the motor head, right? So I put it together, like you'll see, I say, I used a miter saw to grind into this big disc, you know. It was poor man's job. But it worked. Like, it was my goal to make some of these devices for absolutely free. So I found these ceiling fans in the garbage, and I made them into one of these systems. Everything but the glue I think I paid for on some of these motors. So I made hundreds of different modifications and different types of systems here over those years. And it was, at the beginning, it was all volunteer, right? Until I finally, people were begging for chargers and motors, so I made them. And that's how Renaissance Charge started. So what happened was, in 2006, I started on that lawnmower, and then it sat most of the winter. And really what it was is a portable generator. So it's not really about cutting the grass with it. It was about having this thing be able to travel somewhere and power something for free. And I did have like another generator hooked onto a pulley on top of it. But this type of system is not really about a motor. Like, I just made it a motor too. It's about charging batteries, more batteries than you're running off of. And that's what this meeting is going to be about. You're going to see something extraordinary. Getting into the more advanced, the highest advancement of this battery charging technology. And again, we're limiting this to 300 people because I don't think it's fair to people to have more. It's just a lot of people at a meeting, is not going to work out. So anyway, I did this 2007, or no, 2006, the bigger motor, like of the monopole. And I was going up hills that were pretty steep. When Newman showed his car running, it was on flat ground. That's not impressive. But if you can go up a hill, then you're really pulling weight. Now, when I converted that lawnmower into the window motor, which we're going to talk about in a minute, I was going up a really steep hill, and it was 10 amps at 36 volts, while I was charging another battery. So I'm going to talk about all the parameters of that in the meeting. It's too much to get into here. You can watch some of my other videos where I get into all sorts of details. But so I made that one motor, and everybody was shocked because everybody said, "Oh, it doesn't have any mechanical power." I said, "Oh, really? Let's see." And so I showed that, and they were all amazed. But then, okay, so that was you're going to see some of that video where I go through the payload parade, Memorial Day parade, 2007. And then it progresses to this type of motor, the window motor, which then at the 2010 meeting, I had that with one coil in it. And they were 40-pound coils, 44 pounds or something like that. They were PCV pipe, 4-inch pipe, a big loop, where I cut around the whole piping so that I could wrap the wire inside. And my son, who is a power lifter, who's one of the best coaches in the world right now, it's funny because I remember him when I was winding thousands of coils on my front lawn, like especially these, well, the bigger coils like in there. And so I was winding these bigger ones, and I just remember him, he's so little, and he tried to pick it up, but he couldn't. And now, you know, he's like this major coach, and he's won the nationals and what all that. It's kind of funny, but anyway, so I wound those coils, put it into that window motor, just the one first, and at that meeting, 2010, I started it off, and you'll see a little clip of that, probably on the second day you see the clip, but I remember I started it off, well, I drove in, and I didn't know that this was coming, and so I drove this rider lawnmower, and that's why I want to do a golf cart this time, maybe the same way. And I drove in, and so everybody was amazed. And the second day, like, I popped a wheelie. So we had a 200-pound motor on the front end, and I went whoop like that, with only 10 amps at 36 volts, right? Anyway, I would drive that thing around a lot for the next while. And then I decided, of course, the next year, let's put more coils. So I put 2 more, 3, as you can see, and that went into the boat. And then I converted that lawnmower back to the monopole system. But in all these meetings, someone's always sabotaging my systems. And so that one never got finished, just like the big Ferris wheel didn't get finished. And there was a whole bunch of drama behind that too. Guns pointed to my head, literally. It was unreal. So, that's another whole story, private story. Okay, so then after that, I ran that boat for 3 years. I got it running better than you see in the video, because you got to understand, I show a timestamp there, and it was like the 27th or 28th of the meeting, and I literally started like a few weeks before. Like, you can see the progression. So what we're doing there is, I ended up, to be clear, so you understand the progression, I'm trying to build established control, right? I'm trying to do science here. So what I did was, I took the motor, the forklift motor, out of the Honda, and I knew exactly what it did in the Honda, and I wanted to see what it did in the boat first before I put my motor in, so that I can compare it. So just to let you know, again, the numbers, which you'll see if you bother to look at all the details in this, but I'm just breaking it down for you right now, is that I had the Curtis controller that could do, I think, 500 amps for 2 minutes at whatever voltage. So I was running 132 volts in the car and in the boat, and I think I went up to 144 in the boat with the Curtis controller, and then it would go and limit itself to 350 amps, I believe. And so I could go across Lake Coeur d'Alene back and forth. It's 185 miles, I believe, altogether. And I've seen 6-foot waves on that lake, by the way, while I was on that lake. And so I could go across and back with the cruise controller with that conventional forklift motor for 350 amps at, like, let's say 132 volts. So you do the math there at 7 miles an hour. Then I could, with my motor, I never went over 24 volts. And I never went over 50 amps. And I could go 5 miles an hour, going 50 amps maximum, and that was rarely that I ever did 24, but let's just say I never went over 24 volts at 50 amps, 5 miles an hour. Yeah, 2 miles an hour, you know, at wake speed, you might not say it's significant, but I'm not planing, right? So I'm dragging in the water, you know, an 8,000-pound boat. So that's how efficient the motor was, plus it was charging the other battery for free. And I ended up using that boat for 3 years, not in the wintertime, but I did use it all spring, summer, fall for 3 years. And then I sold it because I was moving back out east here, and you can't really transplant boats or whatever. So that's the history that you'll see there, the progression. So since then, like, that's all kind of, these motors are all kind of old news, but there is some new motors that we'll be showing. I mean, these are significant. For some of you, you've never heard of this before, so it would be very significant. And these motors right here are very significant. With these ones right here, we tend to do some other advanced processes that aren't motor related, right? They could be done either solid state or motor. But if you have motor, you also have that free torque, right? So as I said, and I'll talk about it and show this in the meeting, we can do, without losing any motor torque or taking any more input energy, we could create heat, torque, light, and battery charging. 4 outputs for 1 input. And of course, there would be no input anymore because we could rotate the batteries around. And so we could have torque, light. So magnetism is a free byproduct of electron flow. Same with light, and same with heat. The whole explanation of efficiency is wrong. So I will get into this in great detail in the meeting. And that's updated from even the last meeting. I've got a whole bunch more articulated. So I'm just speaking in random here right now. What else in the video that you will watch now? So I'm not including so much of the video because this is already very long. But I wanted to really cover that history so you can see what to expect in this next meeting. That's the context of this next meeting. It's to be of this caliber, that's this level of demonstration, and but a lot better and more information, and a lot of product as well. So that should cover it for now. For those of you who are coming, I look forward to seeing you. And we'll see if there will be more videos explaining this meeting coming up. Thank you for watching, and enjoy the rest of the documentary.
Well, I want to thank everybody for coming out. Some of you guys came from a long way, Australia and China and Europe and all over the place. So we're going to just look at the Porsche, the lawnmower, the big wheel, and the boat, which is docked over there. Renaissance is a company, it's a private company of mine that is involved in sales and research and development. It's about 4.5 years old. And we are interested in selling battery chargers, of course, that allow you to restore batteries, allow you to keep your batteries, and save the environment and so forth. That's a major focus of our company. We're going to offer a full line of chargers for every charging application. That's our plan. And secondly, we want to get into this alternative energy, free energy technology, which we've slowly progressed in bringing out in kit form. Many of you have received kits, and all of you will receive a kit that will be a new kit for us. So that's what we do. Let's begin focusing on the Porsche. And before I walk over there, I'll just give you a rundown of where it's at. So the Porsche is capable of about 50 horse. It's actually a small motor, even though it's 10 inches, almost 11 inches in diameter. It's relatively small for a magnet motor. It's only got 2-inch coils inside, 3 sets. Strong magnets, but a 6-inch rotor. So I really wanted a 14-inch motor in there to really give me the power that I used to have in there. A couple of weeks ago, I took out the conventional motor that was shown in the last convention, November. And that had a race motor that was capable of about 2,000 amps at about 300 volts. So basically I had to start that thing in second gear, and I could peel out for quite a while in second gear. I blew out my transmission a couple weeks ago because of that, and so I had a couple of delays, but it is about capable of what my Honda is capable of. It's just a small electric vehicle conversion that we have, that we did about 2 years ago. And that gives you basic city driving. You can go on the highway, but it's, pushing it. Most of these electric vehicles are just commuter vehicles for the city that you don't want to sit in traffic and burn fuel. So the motor that that's in there now will be approximately that power performance. You'll see right now in the Porsche, especially in the boat, the parts that I'm using in there are like really big and bulky, and it's nothing special at this point, So a comparable controller would be probably much smaller, But hey, no other controller can allow you to charge another battery while you're running a motor, and that's what's all that matters to me. So that's the claim here. That's the purpose of this convention. It's a hard claim to make. There's a lot of skeptics, especially in this country. We have other countries here today that are a little bit more interested in believing more alternative technologies, accepting them, and just readily wanting to use them immediately. But all of you are here personally to discover that, to benefit from that, and I think we can do that. And hopefully, over this weekend, we can really cover what we need to cover. Last year was kind of scattered, didn't really have the amount of time dedicated to doing that. And this year we want to really open it up for the questions and the demonstrations and just going over, well, this is what you do, this is what you avoid. There's plus side and there's negative sides. So this is an 84 Porsche, and my dad should be here somewhere, or he took off. Last year I dedicated it to him. His name's on the window. It says Peter Carl on the side. My dad's from Stuttgart. His car was built in Stuttgart. Had to have the Porsche. I used to be a Volkswagen mechanic, and this is basically a Volkswagen. It's not really that hard. The hardest part of electric vehicle conversion is mounting the plate and just getting yourself exactly aligned. And we did have a problem with that. Right here you can see that the motor is resting really pretty well touching the front suspension, or the axle, or not axle, the steering column. And cross beam. So you have to consider several factors, especially in a magnet motor, and I'll go over the parts in a minute. But you have to consider where you place it. On a front-wheel drive, you have to consider how wide your motor is. Like in my Honda electric vehicle, it's only got about 8-inch clearance. From the drive shafts, one of the drive shafts going across. So
you keep the same transmission?
Yeah, so we keep the same transmission. Unfortunately, I blew that out a couple of weeks ago, and we put an 85 transmission in there, which I'm looking forward to testing out. Thing about electric motors is you got power right up front, bang. So you got to watch the transmission. We usually take the clutches out because you really don't need them, but you have to watch that you don't strip the gears. So in my Honda, I won't mention who stripped my gears the other day. So if you're like, don't accelerate hard and then...
Automatic car is okay too?
Automatic takes a little bit more work, but it can be done, it's doable. So typically you have 72 to 144 volts in an electric vehicle. It really depends on the room that you have. Right here we have the front batteries. 6 batteries I can only put here. We did have a 7th on the side there, which probably I may be able to squeeze in, but actually I'm going down to 48 volts on this system. So typically you have 72 to 144 volts. To get you, if you have 144 volts on a small car like this, you can probably go in the summertime about 70, 80 miles at the beginning. And then you lose battery capacity within a very short period of time, so you have to replace your batteries. You might lose half your capacity within 1 year of regular driving with conventional chargers. So with my charger, which we have here, I showed that last November. I've used that every single day, and now I'm using it in my Honda, which has the same batteries in them, except for last night we moved them over here. I've used that every day since October. That charger, which is a prototype still, we'll be selling that in the near future, but it's hard to say exactly when. But that charger has increased the capacity of my batteries about 10%. And I know exactly what's in my batteries because I go usually the same distance every day. Typically, like I said, you can go farther in the summer, 70 degrees, maybe 60 to 80 miles, depending on the condition of your batteries. And then in the wintertime, maybe I only get 30 miles. So it's not really all that practical. It's not really that practical for most people, electric vehicles, because you have this enormous cost in batteries. So $3,000 of batteries every year, every 2 years maybe, is just not worth it. You know, if you feel like maybe you want to save the earth and the environment and you're a rich man, you know, that's the typical customer, unless you're a hobbyist and you like to do that kind of stuff and think around. It's really easy to do, as I said, to do a conversion. So what we're going to do with our motors and controllers is make them pretty much identical, and it'll be a little bit bigger. The controller will be much smaller than what this is, but it'll be basically plug and play type of system that allows you to do the same sort of things, except, you know, you get 2 Anderson connectors to 2 different banks, and you just swap them around like you'll see in the boat. You can find a hardwired mic. So we have 3 sets of coils inside here, and you'll see on the kit, it'll be the same thing as the kit. We have magnets, we have 4-inch magnets inside. That are neodymium, and the objective in what I was doing there was I have to have stainless steel around the outside, or maybe very hard plastic or something, because you cannot block out the magnetism. So you have, you know, a certain area that you have to have clearance on. So we raised the controller up about 3 inches above the motor, which gives me about 6 inches of clearance from the magnets. And that, you know, will still create a little drag. If you know that if you ever take a magnet, especially a bigger magnet, and run it across aluminum, there'll be a drag on there, and on steel it will attract. And so, you know, that's what we have to deal with. That is one of the limitations of these systems. But you can see it fits in a typical car here. This is rear-wheel drive though, so. Here's an important point. If you don't have a sufficient load on this system, it will blow out. So if you have a fully charged battery, then it needs to be discharged. Otherwise, this won't see a load, so to speak. You know, whatever. So the point is, that is a limitation. That is a difficulty, and it's instantaneous problem. It's not something that we could put in there to prevent that from happening. I mean, I've got some ideas that can be done, but the point is, there is a certain responsibility for these systems, and you got to be careful in using wire clips and stuff like that, and not have sufficient contact on the charging side. You can see a little sign on John's 10 coiler years ago that says simply, hook up the output batteries first. Because you might forget to do that, and you lost everything. So that is one reason why this kind of technology is not come out, because it's hard to work with. Engineers are not taught that this is even possible. Now, there are numerous engineers here today. Some of them are helping us out and have been over the last couple of days, which I want to personally thank. Not at this point, but we will do that when we go inside. And they, you know, have repeatedly told me over the years that you know, their field of study has introduced them to certain phenomena that's related to this. And most of my customers are between the ages of 55 and 65, maybe 50 and 65, who are engineers who know there's more to it than what they've been working with, or they've seen things, and they're interested in exploring. Is it a benefit if you got to replace your batteries every couple of years? You know, like going back into that, conversion process can cost you anywhere from typically $6,000, like on my Honda, that would be the low budget model, to typically $13,000 for a bigger vehicle. You know, $3,000 of batteries, $2,500. The Porsche before. $2,600 motor, $2,600 controller. You got some wires, you got safeties. So you got to think, well, I only go so far. So now you can keep your batteries. So it's really exciting when you can actually take this the extra mile and not have to worry about it. Okay, another thing with electric vehicles is you get one cell that's bad, and it's going to bring the rest of them down. It's going to reverse, and it's going to cause you all sorts of headaches. So what our technology has done is, we sold some electric vehicle chargers for a couple of years with pretty good success. It had some limitations on that charger, and we took it off because we're redeveloping a new charger. But it would go through the whole string of batteries and find that weak cell and bring that one back up. Oh, okay, so at this point I'm going to say I've had some 2,000 amp hour batteries, and we were all set to bring them last night, and then we realized they did not have a forklift here. So these batteries were varied. They were 15 years old. He used them, he bought them 15 years ago. These are big cell phone tower batteries.
I got some.
Yeah, they're like, basically $1 per amp hour. So you got 2,000 amp hours, $2,000 per 2-volt cell. So you're talking about a lot, 400 pounds of batteries. Those batteries are great to get if you can find them. So again, that's the battery rejuvenation benefit, which you can do with the motor generators. Usually it takes a longer period of time because most people will not create a motor generator system this size, which would be equivalent to some of our larger chargers. The benefit of this over our other chargers is that you get free motor power, or free charging, or free light, or even free heat. We can do all those variations, or all at the same time. We can do that. So that would be an ideal situation. Oh, what? Okay, so we got to move on. Let's go over to the lawnmower. Some people are sitting down.
What was the range of this?
So this range was about 80 miles when it was a conventional motor.
Let me get some film.
Okay, here we are, riding this lawnmower down the road. The last one in the parade. Of course, I haven't finished building this thing. You can see it slowly moving. And I got my voltmeter here, 22.6, so it's drawing. The more load I put on it, the less it draws. Got my trigger resistance right here. Got a couple bulbs in the front. Somewhere there. Which function as lights. Now we're going to have, this is a memorial parade. And you can see down here, the graveyard. People are all gathered. So I don't have the seat on very well. I'm in 6th gear, so I'm going pretty slow. But you can see when I pop the clutch,
and I stop, watch what happens. The wheel spins faster and it draws more. 22.5, 22.4. It was when you suppress the motor, you reduce the current flow, but you still have good charging. Or better. Now you can see we're going up the hill. It's even higher. Okay, here you see the resting voltages. Well, just after I turn it off. So this one is going to be climbing back up. And this one should be about stabilized. So it's not tuned at all. There's my switcher. And I got the bulbs here in the front. These are full brightness. 7 watt and 11 watt. 7 watt and 11 watt. So I don't have the proper connectors here. So you can see that one's climbing back up. That one's stabilized. One's already going to 24. I should say also that these batteries were not fully charged to start with. They were pretty much where they are right now. So this drove a good mile up and down hills. Okay, we prime this thing up and let it sit for a day. We'll put some nice metallic paint on it. You have to deal with certain factors. Okay, so what voltage are you going to run? Okay, running at 12 volts is much different than 24 or 36. So, like John's 10 coiler, for example, when I run that at 12 volts, it's only drawing about 2.5 amps. When I run it at 24 volts, it's 10 amps. So, unless you change the resistors, these are base resistors, base of the transistors. Those are big 5 watt, only 10 ohm. So we were going to really push those really hard. That's why we had 10 on there. And when you push it harder like that, you can get out of the sweet spot. But not have the greatest charging power. But sometimes you want to just push it hard to get the job done. Anyway, so you have to consider, like when we're testing out a system, we start off with one wire, and that's what I did the other night. I didn't do that, I just rushed it. I'm operating on about 1.5 hours sleep the last couple of weeks. So kind of switched it sequentially, and I just run the whole 24 transistors in one shot, because I went up from 12 volts to 36 without properly putting enough resistance on there, and then transistors just couldn't take it. And actually, the other thing I just remembered is those batteries were already charged. And that's again, discharge otherwise when you push it that hard. We want to move into this big turning point where we want to move to the next stage in this technology and start building fully assembled systems. People have been asking me probably every single day. I get an email or a phone call or something from some wealthy person or whatever saying, will you come over and build a special system? And it's a difficult thing to get into, but we want to move in that direction. And we need the right financing to do that. We need the right people and so forth to make it happen. But we are starting to make more and more of these systems assembled, such as we already do with battery chargers. So yeah, it's difficult. It's not for everybody because there's patience involved. Now, for the
the guy like me who loves to see the finer points of science and wants to see little things here and there and tinker around, it's great. But the other guy who's like, hey, I want to cut my bill right now.
Yeah, that's 30 Go back. It's very simple. It's not coming over here. Well, it's like when you learn your ABC.
So when the machine is running, is this part up here generate energy as well that goes to the charge battery?
It's go time. It's go time, man. One of them is
So I gave him
now, and I told him, I said, honestly, we knew coming here was going
but what happens when I have 12 volts the batteries in series with the other guy. How much? Without disconnecting. There's a great industrial supply place in town. They used to give me metal because they knew what I was doing. And I had no money. I was like broke as a joke. I still am, but I was worse off. And so these guys gave me this metal, and I just put two plates together. And it's not completely balanced, but hey, it does the job. So this is aluminum, and then these were cut out with a miter saw. Whatever. But anyway, they were glued in there, and that's probably. I think I just put epoxy on there. Yeah. You know, it's so long ago. It was anyway. So that it was just a bigger disc. I said, John, I'm gonna do it. 25-inch disc. Oh my god. And I did it. It was like put a smile on your face. So it was a neat experiment. Like I said, these coils were a little close, so if I would have had more time to do this, I would have probably spaced them out. He finally discovered that rest is very important to battery charging. So, like in my rejuvenator, I wanted to have a rest period between the charging and loading, for the health of the battery. But the other reason is, if you charge the battery right, the right way, it will continue charging. So here we have a rest between here and here. So ideally, you have to find what kind of rest period the battery wants. Whether very short rest period we're talking about, or resting for a few seconds, either being charged or loading. Very important. This is one of the most important things we can talk about this whole weekend. And if we're talking about free energy and maximizing our efficiency, you have to read what I wrote years ago about that on the groups in all my experiments that I did. Doing, timing. Like John, if you look at his old systems, you see 13-second pulse. Once every 13 seconds sometimes. It's like, well, what are you going to do? Well, so for example, my 10 coiler, when I first put it together as a prototype, I ran it for 5 minutes, and I had some batteries on there that continued to charge, significantly, for the next couple hours, just for running for 5 minutes. So you can start to think several battery banks, the right rest periods, you can shuffle around a lot of energy. The batteries keep charging when they're rejuvenated. So there's a lot of factors involved in this. It's not just about, okay, how many windings, how many this, how many that. You gotta understand rejuvenating a battery at a time. You gotta understand several things. Like, for example, electric vehicles. You have the cold and you know, basic concept. If your battery's cold, it's going to give you less power. So in the same way, constant current, you kill the dipole, you have to fight against it, you create heat, you create all these things okay, does your body operate that way? No, pulses. A heartbeat, that's what we're doing. Nerve impulses. You know, unidirectional wave impulses is what we're doing, apparently. I'm not a physicist. Anyway, so the point is, there's all sorts of factors involved here. And what's the ideal system? Well, there's so many factors that we can change. For example, we use just readily available welding rods. You know, we use 1/16 because it's less eddy current, it's less drag. I mean, you'll see there's a sort of a magnet lock here, and then when we spin it, it sort of freely spins. So that's another, there's no real drag on these systems. That's really weird. But we could use different material there. So 132, we might change over to that in our kits. It's a little bit harder for my manufacturers to cut and work with, so, but you know, they're going to give you a little bit more benefit there. You could use, you know, we've tried black sand, we've tried all these different core materials, and you could go forever improving that kind of stuff. And then you can get into the shapes, like I said, you're just turning, obviously, the coil in a slightly different angle, you know, to maximize benefit for rotation. Let's move on to the boat. Okay, so here we are, Hayden Lake, driving for the first time electric. I might not have the gear linkage correct here. Got some water still in the exhaust hose. Here you can see I got 120. We're down to 11 volts. I'm not going to push it hard because I don't have very big wire here. But as you can see, we're moving. We're getting faster than that. So we're going to turn around and go back. Alright, we're going to put some more speed to it. Get it going here. That's about all she can do at 120 volts. You can see we're cruising about 7 miles an hour.
All right, here we go. 12 volts, and I'm running the ship. Making sure that I don't hit anybody. I'm going so slow. We are in Coeur d'Alene Lake. We've got only a very small portion of the motor hooked up. And there's the circuitry. Anyway, that's it. Only 12 volts. Only one of the circuits hooked up. And we're going to cruise here tonight. Well, here we are again, second day out around the Coeur d'Alene Resort. Just going to go and do a little tour of what we're going to do, where we'll give it the boat tours. You can see we're running off of only 6 volts right now. Really low speed. And we have full recovery, more than full recovery in this system. So I can go on for as long as I want. Stay out here, travel the world. 6 volts isn't very much. Of course, I'm only going 2 miles an hour, 3 miles an hour. But I'm just testing everything out very slowly to make sure. Okay, what are some of the questions? Well, I'll get to them at the resort. Oops. So here we are, here's the boat. Some waves here that we gotta deal with. We'll turn around here. Anyway, this is the first Bedini window motor boat conversion. Let's look at it a little bit more. We've got a timing wheel. Better turn around a little bit better. A little sharp on the turn there. We got a timing wheel. We've got one side, a set of circuits here for one side of the coil, or one coil, sorry. And then the other side is over here. So we have 2 sets of coils in this per 2 sets of wires, sorry, per coil. And I don't have them all connected yet. That's the main one, which I haven't connected yet. Make sure I turn straight here. And then we have some of the gate drivers over here, and that's where I experienced a little bit of hot temperature yesterday. So I wanted to test it out today again to make sure everything was good. I don't have cooling yet in my water cooler. And I've got some fans, which I don't have on right now. I should. I guess I'll do that in a second. Then I have a whole bunch more batteries, but I don't have them hooked up, so I don't need them. You can see that's the positive, and it's going over here 18 volts, but I'm only really going off of this positive to there. So that's only 6 volts right there, really. And that's it, I guess. What else is there to say? I do have an extra motor, gas motor here. It doesn't work actually for a backup, but it's not deep enough in the water. So again, what we have is the big window motor that was on the lawnmower. You can see 3 sets of coils. And then I had to put a belt drive on it. Well, here we are taking off the Coeur d'Alene Resort for our convention day, July 29th, 2011. And it's a beautiful day at the Coeur d'Alene. Nobody's out yet. It's about 5:30 in the morning. And we're just going very slow here on purpose. Making sure everything's going to go right. I don't want to push it too hard. So you can see this is our sort of final setup, at least for the day. And there we have our window motor. Of course, I have a piece of metal down in here floating around, hanging around my controller, of course making some noise. And this is my controller here, water cooled, which I don't have on right now, and air cooled. Just the SG circuit, as we call it, schoolgirl circuit. And I gotta turn a corner here. So here's this beautiful sunrise coming up here, Tubbs Hill. Lake Coeur d'Alene, and there's the resort again. I'm going to drive around here, and so what we have right now is only 6 volts, and not many amps here. I'm going to put my amp meter on this thing, see how much amps we're actually drawing, but it's not much. And are we charging batteries? Yes, we are, like always. In fact, what we're doing with this motor is 2 types of charging. One being what we call the radiant spike charging with the basic Abedini patented process that allows for an open loop system with the environment, providing extra energy, reducing the back EMF out of the system. You can read the patent online. And we also have very strong neodymium magnets here on this rotor. 60-pound rotor here. The gold rotor moving around there. And that passing by, let's see, about 100 pounds of magnet wire. We also have a regular current also charging the batteries as well. So we have 2 types of charging here to keep us going. And so if you look at the one wire down there stretching across, it's only actually operating at 6 volts. And I only have 24 volts on either bank here. The charging bank, which is in the cabin. I'll show you. It's right here. So we got 4 batteries there charging up. And I will say that those batteries were useless about maybe 6 years ago when we got them. They couldn't drive an electric vehicle down the road. We restored them 100% capacity. And used them in my Honda electric vehicle for about 2 years. And now they're put in the boat. So, except for that one battery over there. So we have 2 batteries over here And these two get used if I want to push it 24 volts. 6-volt golf cart, Trojan, T105 batteries, and one interstate over there. So here again is a beautiful Tubbs Hill, south end of Pearl Lane on the lake. And there's the resort early in the morning. Hope to have a good day on the front lawn, displaying this boat, getting some boat rides, displaying the new Porsche conversion with our similar motor, which is about half the size. We'll show later on today. And also the lawnmower again. And the 13-foot Ferris wheel we'll have there early this morning. So there you have it. It's running relatively cold. I have a lot more work to do on the circuit to use different devices. These are right here, gate drivers, and I got big resistors on there. Just playing it safe right now in the time that I had to prepare for this convention. You know, big circuits lying everywhere, and that's all right for now. But we'll miniaturize everything, get the right maybe FET control instead of transistor control in there. That's all part of the R&D. But we've been using these components for years. I just wanted to show that, you know, you could drive a boat with, you know, about this size, 26-footer, maybe 8,000 pounds. You could still drive this motor relatively easy with a big bulky controller there. And so, anyway, we're going to be heading into this other dock here to give some rides today to people who made arrangements already, maybe some other people. And these other batteries here, I should say, are the accessory batteries. And that was the starter battery. And we've got a belt drive here as well, because we had to get above the ground. I didn't want to go too close, just in case we have a little water come in when we're docking, or with the big waves and all that. So we put a lot of work into this conversion, and on the top here we've got some solar panels just for the radio. Anyway, old boat, 1979, which I don't need the fuel tank or the gas gauges anymore, because we're all electric. That should be it.
Negative concept.
Into water charge, if the temperature increases or other parameters change. Have you done any research on monitoring some of those parameters and then dynamically changing the tuning?
Yeah. That would be a question for tomorrow. Okay, so obviously we can't all come down here. I'm not sure, is there a sign that says maximum number of people on it?
10 for the water stuff.
Let's keep people up there.
Over the top, you know you're at their limit.
A couple down at a time. And can you still hear me up there? Good. Oh, gotta go on.
You don't have to. You can go unlimited since you're constantly rejuvenating the batteries while you're driving.
Can I get in here, guys? Or hold the mic up here. I'm sorry, what was your question again?
Oh, about unlimited distance. If you're rejuvenating the batteries while you're using the motor, then you're not limited to 80-mile range, right?
Exactly, that was my whole point. That's the only reason I want to do this is, I mean, that's not the only reason. There's a lot of reasons.
So, okay, so here we have the boat, everybody. It's not the prettiest thing, and I want to do a body wrap.
It's
I
beautiful.
really wanted to take these out, but that's just for my stereo, the solar panels here. So, and again, I'm not opposed to using the sun. So anyway, this is capable, as I've always said, of about 100 horsepower here. Now you can see it's not a pretty thing. So, the coil forms in there aren't really fastened down where I'd really want to drive it that hard unless I still support it a little bit better. But we have it down there pretty good, and it does the job.
Could you point out the components?
So let's go through what's involved in this thing. Only a couple of weeks ago, I had the motor that's in the Honda in here, just as a trial run to see what it would do on the water and balance out my batteries. And so we ran that, and look at this. I could go about 7 miles an hour on this boat with the Curtis controller, with the 13 to 44 horsepower motor that's in the Honda now. It's only rated for 120 volts, but we ran it 144 volts in the Honda and in the boat here, and I could go about 7 miles an hour in this boat. And the Curtis controller would get too hot, and it would actually limit me down to 3 miles an hour. And so that was 300 to 350 amps at 144 volts it takes to move this 8,000 pound boat. So I've shown a couple of quick videos, and right now I was only running at 6 volts. 6. I've got capable of 24 volts in the system here. I've got 24 in there and 24 out here, and I've got some accessory batteries for the radio and so forth. So at 6 volts and 100 amps, I was going about 3 miles an hour while I was charging. Actually, when I did that, I had 60 volts charging at the same time. So that was pretty good. You do the math. As I said, I don't want to push it right now because of the way this controller is. And I'm going to show the circuitry right underneath the lid. Oh my goodness, I forgot to spray paint that. So what we have here is this same old circuit, the SG circuit, and we have a we're not using all those components there. We have 3 of the boards on each side are not being used. That's just the way we put it on a big aluminum block so we can water cool it. And apparently I've got some water coming into the boat from the water cooling thing I have to look at in a minute. But anyway, what I'm going to say is SG circuit, just like in the car, just like in, well, it's like the one in the car in that it has the speed control, which is in this box right here. And that is merely a 555 timer that I've been selling in what we call the advanced kit, which is in page 40, well it was page 47 in the old book, of free energy generation. Have you guys all seen enough? Because we've got to let some other people come up in order to get everybody to see everything. So what was that timer? It was just a pulse width modulator, changing 2 sides, a variable's pulse and width using the SG circuit. So, hey, not rocket science that to do that. It was something simple. I was having somebody else make up another controller, but that did not work out. It cost a couple of timer. I had to actually multiply the transistors driving the gates. So I mean, this is not the way to do it at all. It's just a simple way
they threw together, and it accomplished the task they want. You know, I don't really care if I have to add a couple more transistors here and there. And in this case, I got all the room in the world to add the circuitry to. So again, this says 3 coils. These are about twice. Well, the original coil in here is 47 pounds. That was in the lawnmower for years. And then I added 2 more 25 pounders. And so it is kind of a balance there, but it does the job. And again, the limitations on this is these are very strong magnets. I've got 300 pounds pulling force doubled. And then I have the magnets again, north poles facing the north poles and south poles facing the south poles as you go around. So you have this, what some describe, John, a scalar beam type of thing going up where you have a condensed field. And the reason, what I was getting at before, one of the benefits of doing that, John said to me some years ago, he said, you gotta watch when you're using the neomagnets, because if you don't get the geometry right, then you're not going to get charging, because your fields overlapping each other are not going to work. They're going to counter the charging benefit some. Because in this particular case, what we have is 2 different types of charging at the same time. So we have, you know, your typical generator function where you have a magnet passing a wire, right? With no iron in it, too. There's no iron in this motor. And we'll get into that tomorrow when we build the kit. But the point is, you have to space the magnets, or the coils, just right. You got to map out the fields. You got to see really where you want to place that coil, and you want to place your magnets in the right position too. So that's the thing to work out. And you know, it takes time to build prototypes and do this stuff. This one was just something that we did and it worked out. The limitation on this again is I got a steel frame, probably only just about 6 inches away, and that creates a drag on the system a little bit. So, you know, I should have had stainless, but that's what I had some years ago. So it's a pretty big 21-inch, I think it goes across 21 inches from edge to edge. The rotor, this weighs 300 pounds approximately. 100 pounds, or yeah, 100 pounds of wire, a 60-pound rotor, really heavy steel end plates, and then the other components in there, like the bearings and stuff. So, so you know, under the right manufacturing conditions, if I had put this together, you know, a little bit better, I would push it more, you know, but there is obviously a breakdown limitation. Oh, for example, what we'll say tomorrow, when we look at the kit, we actually ran the kit extremely fast at 36 volts until it literally blew up. Now we usually use, when we do stuff like that, we usually put string tape around it. And we, you know, that allows you to, you know, to keep the magnets from flying apart, even if they break off. So the brief construction of this is we have a belt drive, so we could keep it above the water. In this case, you can see a little bit of water on the bottom, so I got to pump out. Hopefully my pump works there. And we've got some aluminum 1/4 inch holding this motor up, aluminum plate on the bottom. Everything's resting on. It was a little bit of a pain to balance this out. And, you know, John kept saying to me, get a straight drive, get a straight drive. I was like, well, you know, I really wanted a cabin cruiser for my family. We had this old little boat before, and there was no top on it, and, you know, everybody's getting sunburned. So that's the only reason really why I put those panels up. So, you know, if you have a motor fully assembled, and you have the controller fully assembled, this is pretty easy. You know, you pull that motor out, and actually, I had to fix, you know, the out drive on this, and the motor had a leak in the exhaust, and so we got a good deal on the boat. We pulled it out relatively easy, and you know, it's a pretty easy conversion because you can just get right in there. You know, whereas like on some cars, you have to like go around a corner here and there's just not much room. I mean, this is way big. When I wanted to put this box on the Porsche, the guys that do custom stuff next door to us in our shop, next door to our shop, they were like, "No way, you can't do that." So they made that box for me. Chris at Odd Cycles, great guy. You know, if you're local, he's the man to go to for the bikes.
What
He does the
RPM?
Harleys.
What RPM does the motor run at?
This one, well, under load because of the propeller, depending on the voltage, really. So I can run this. It's relatively low RPM to get you moving. Right now it's 6 volts, but in time I'll get this up to 30 miles an hour, or whatever that is in knots, and that's about 4,000 RPM with the gas. You know, so that's what I'm going for. But you know, I don't usually need to go that fast. But
This box provides fuel?
yeah, so this is the, oh yeah, so you guys get to see it. So this is where the control, this is one part of the control. This box right here, as I said, is the black box. This is the 555 timer, and it's just, you know, running these, just driving the gates at the time I want to have speed control.
Instead of the off-road.
So like I said, the other problem that I have, actually I do have an extra coil on there underneath, but I haven't hooked it up to it. If it falls in the dead spot, then I'll have to go and put it over. That's why there is movement on this motor.
You don't know very much.
There's a lot to learn.
You don't have it. So this year, I brought two other guys.
Oh, really?
You know,
I
some of the
brought this other
guys,
guy. He actually he was talking about
It's like a resource based on like monetary is just exchange. It's just simplifies the exchange of resources.
water and car to start. Although this, you saw me pull Billy on this.
well, see, he's got. No. See, I brought it.
Right.
But anyway, this one I was running, and I'll go get the ammeter.
He's designed
We've got
for NASA.
200 ammeter, so we could probably put on there. I had it on earlier, but I have,
He's still,
like if you see my video, I
he
have
got the masters from Stanford,
here and there.
He's still in
So I had to put it in the box. But I had to put it on and actually
he knows how much
that went quickly.
he knows how strict it is.
But so
Now stick your arm in. Speed.
Also ginning the other batteries over here from up there.
Just doing it himself. Primary current.
So what's the load up there doing?
Just holding the motor stable.
So it's not, the energy that this is generating is not being used. Why not? Could use it to charge the battery.
You could. But it's hardly gaps at the right spacing to be a magneto. Understand? You have to close the gap. Why do that? Why do that? You're already recharged, already on the pin of the 36-volt system. And the primaries aren't doing anything. And the axial motor you can't read. It doesn't need any more current.
Oh, by the way, it's been great to meet you. I'm RS.
Play with it all you can.
Well, I don't mess with it. I don't know.
Positive. So we talked about very positive.
Right there.
You told me about this 5 years ago.
What's happened here?
Well, I've done a lot of things, but not this.
Look how easy you can say.
Oh, this must probably trigger here. Judge. That's pretty much it. Just that.
So,
Transistor. Two diodes.
So they're,
the point is,
the grid may not work at all.
we have two kinds of energy. If I just spark up the VST circuit, what was this phenomenon he found? And he mentioned this way back in the 80s. Was when you negatively charge battery, for especially like for a long, I got you. You want to hold that up there for a second? Okay, so we're going to go real slow. I got to turn the fan on. Fan. So I mean, I don't even have the holes, you know, I need the bigger holes here and cover that up. So this one's blowing that way, and that one's blowing that way. Okay, so are we untied? Nope. Okay, you want to do the back? I want to drop everything. I usually on the other side. So you guys gotta catch me when we come back today. Just give me a little push out there. Just give me a little push out the front. Not that much. So we're gonna go just a little bit. I'm just gonna go around there. If I want to push it at 24 volts, well, it depends on the transistors or the resistors that I have in there. I gotta heat sink those resistors, but I would say I had it up to about. I had a GPS tracker. It was about 6 miles an hour. Whatever that is in knots, you guys tell me. I'm doing the voting. But we're just gonna cruise around here at low speed. And so this is what's the difference between the motor is driving. Everybody 6 volts. We're just going real slow here.
The end.
You're right a little bit. There you go, perfect. Gently. Keep going, doing good. Straight back. Straight back. Come on.
Man, that looks really cool.
And that's the end. Thank you for coming. A very successful convention we had. Now it's time to take the toys home.